This is not a guide to the use of actual Feige fitting. Use of a Feige fitting is potentially dangerous and should only be done by qualified personnel operating in conformity with all applicable federal, state, and local laws and regulations.
So what we're here to talk about is the standard trawl wire that we see on our National Science Foundation academic research ships. This is the 9/16 3x19 wire. The 3 is 1, 2, 3 round things made of 19 individual smaller round strands. And what we're talking about is how do you put a fitting on the end of these in such a way that you can tow something through the water. The fitting that I'm going to be showing you is called a Feige fitting, and it takes a bunch of different parts to put it together, and those parts we buy usually over the internet from a company called Electroline. We'll try and put the way to source those in this video. So why would you want to re-terminate a wire? Obviously because you don't have one on it, or perhaps you've seen damage to your trawling end of the wire, you've got a kink, or you've got some broken strands, or if it just looks super rusty in the last little bit. Now, the other thing you want to do is before you get too far into this, you're going to want to think about whether or not you have to take a wire sample, get it sent off to the wire pool for testing, contact them, decide whether or not you want to leave the fitting that you've been using on it if it has one. So there's other things that need to be done. You need to document how much you take off, wire log it, all of those things, so we have a running number of how much wire is on the drum. So before you even get started, there's some things you have to do. Okay, so this is a little bit more of a closer example. We've done a test piece here. This is what a sort of set half Feige fitting would look like. This has not been pull tested, so they would look a little bit different after running through a pull test on the A-frame. And then when we're talking about the 3x19, this piece, if you unlaid it, you've got 1, 2, and 3, and then this should be 19 other pieces. Is that coming through clear in the video? And these individual pieces, if you look at them, they're pretty tough even as a little piece of wire. They can really take a lot of movement, a lot of twisting, and so this stuff's really tough. And this was a Nycopress eye that we've cut off, and you notice that I have safety glasses on. When I was cutting this off, the pressure of putting the eye in it blew the wheel up. So wear your safety glasses. Glasses, ear protection, which is the next thing we probably have to talk about, is if you're going to be putting a fitting on a wire, you want to have a clean end. So that clean end is pretty important. There's a bunch of different ways to cut wire. You can use air tool with a cutting wheel. You can use power grinder with a cutting wheel. The cutting wheel is a thin wheel. The thicker ones are for grinding. Use the thin wheel for cutting. Those can blow up. Some ships have a hydraulic little cutter. I don't have one to show you right now, but those exist. Another thing you're going to need to do this is a good big vise that's really solidly mounted. You're going to see why. You really can't do this without a big solid vise and room around the vise to spin wrenches. So know that you need a big vise. You can't. It would be really difficult to do these just out on deck. So on some ships, we've actually pulled enough slack to run it into the engine room to do it with a good vise. You need the necessary actual parts. So there are 3. This is the, I don't know what you'd call this, the clevis end. You can buy this piece with different form factors. So this one actually we generally use for piston coring. That's why we at OSU MARSSAM have them. You know, you could put a shackle through there or a bolt through there. You can also buy sort of the opposite of that, which would allow you to put something into it and bolt through it. You just have to look at their website and see what they've got. This is the end that goes onto the wire, and then there's this last little piece here, which is the plug, and the plug is sort of what holds everything together. One other thing I should note about this type of fitting is that they are rated really high to like the strength of the wire. I haven't seen a lot of actual, you know, in practice used pull test data on the Feige fitting, but they're probably the strongest way that I know of to put a termination on a trawl wire. So you need the plug, the threaded part, and that. And they're heavy. And they go together like this. Those parts, you're gonna need the pounder. This comes, well, it came with ours when we buy it. That's to pound the plug. You could probably get by with, you know, a punch or something like that instead of that if you did not have it. The other thing that comes with the kits that we have, or when we bought them, are these little wire clamp things. And this goes in your vise like that. Put your piece of wire in there. Note that there's a couple of different sizes. This looks like it's for 1/2 inch and 9/16. It's important that you have the right size for what you're doing. I would not cheat and try and use like a 5/8 thing or a 1/2 inch and a 9/16. That's kind of a no-no for any of this sort of thing. And if you look really close, it's pretty obvious, but you can see that it's actually stamped 1/2 and 9/16 for your wire sizes. So you need those guys, and a hammer, and some sort of wrench or other object to turn what we're turning. And we're also going to be using some never sees on the threads. Okay, probably come up with a couple other things while we're doing this. So the next step, once you actually finally decide you're going to get around to starting this, put your wire into your thing. I'm doing this on a little scrap. If you have wire, it's definitely you're going to fight your wrap. You're going to fight all of that. So kind of you want to get this situated so it's pretty centered, because you're going to be hammering on it, centered in your vise. It's better to not have it out on the edge, because that's a better way to break your vise in half. If you're buying vices, this is a Wilton. The Chinese ones, we have snapped them in half, even great big ones like this doing these. So you're putting a lot of force on your vise, and the more close you can get it to where it's meant to be, the better. Then this piece here is going to go on there and sit down flush against your thing. It's important because we actually have to get a measurement of this. Now when you buy the parts, there will be a little piece of paper that has the actual specific measurements in it. Those measurements are what you're going to want to follow. I'm just going to show you how this works. Follow the instructions with the measurement for this length. I don't have the instructions. I believe the instructions say right around 3/4. That's like a 1/16 less than 3/4. So you also need a tape measure, which I have right here. So the distance is going to be 1 3/4. So we pull this. Well, it's I can't remember the number. It's a little less than 3/4. It is 1 3/4 is what I'm hearing. So checking it, we're at 1 3/4, and we want it to be pretty flat there. Get it there, nice and tight. And then we need to get our bronze plug, which is fluted. It's got 3 flutes, 1 for each. Get that in there. Get it lined up. See how it's kind of all engaged? Everything looks pretty good. The instructions on this are actually pretty good. The instructions state that 1/3 of this plug should remain above this shoulder. In practice, I've never been able to attain that. So now that this is here, I like to start with a smaller hammer. And I don't know if we can see this in the movie. See how it pops off, and you kind of re-engage them. And see how it's kind of going down. I want to make sure that this thing is not tipping. So that's why I'm using light taps, small hammer, kind of having some looks at it to make sure I'm not driving it. It does often want to come over. So just kind of give it some good hits. Keep making sure that those things are lined up. Don't hit your hand if you can help it. Still looking pretty lined up. And you can notice it's sort of almost imperceptibly moving down a little bit. I feel like it's pretty well started. It's starting to go down. That's when I switch to a little bit bigger hammer. And this is why you need a sturdy vise. And then eventually, you're just going to start getting rejected. This is why I said I've never been able to see that plug go all the way in by hammering it. Checking to make sure it's still pretty straight. Bunch of different sides. Give it a couple more hits. And I think that's probably all I'm going to get on that. So the next step that I like to do is you want to check and make sure that these are pretty straight. Sometimes they'll splay out. If they do splay out, take a wrench or a pipe or something and you can kind of creep them over. Bend them a little bit, kind of make it a little bit easier to get yourself started. Take your never sees. This is really important because you're putting a lot of pressure on these threads by doing this. So get a good glop of never sees on. And next step here, put this on. And you gotta make sure you get a real good clean thread start. You kind of hear it crunching. It should be pretty easy to get it started. And by easy, I mean you might have to be sort of pushing down, but you want to know that you're not cross threading. These fine threads you can cross thread. Now at this point, I undo my vise. Take it out because this thing does not like the forces that we're going to be putting on it. You can see I've already been hitting it pretty hard. Put that there, and then this is where you really want to have it centered in your vise on these flats of that nut looking part. So try and get it pretty good. The other thing is I rarely do these by myself. Like to have a hand holder because it's just nice to have company in misery. All right, so then you've got it in there. Twist it as much as you can by hand. It's kind of rubbing against those wires at the top. That's why it's being squeaky. So get it started. yourself a deck spike or a really big crescent wrench. And this is where you can watch your video on fast forward. All right, so I've gotten to there. If you really want to be strong, you can keep going with a smaller wrench, or you could get a big deck bar. The idea here is we want to consume those threads. So you can imagine if you didn't have a big enough vise, this would be really, really hard on it. So it's still turning, you know, it's still getting movement. So still going for it. So it says in the actual instructions that shouldn't see any more than 4 threads here. I think I'm less than that, but I'm going to keep going because I can. And I'm going to call that good. So once I get to this point, one thing I like to check, this thing's warm to the touch, because all that fighting and forcing has actually made it warm. Next thing I do, take my bar again and I back it off. This fitting does have an inspection hole right here. Inspection has to do with doing an inspection and looking at how your threads came over or your wires crossed over the top. Notice how much easier that is? So all that work and all that fighting, threading this on with a pry bar will get us to something that looks like that. So when it looks like this, one of the reasons that I am opening it up for inspection is I want to see that these things are all intact. We haven't broken off like a whole bunch of these somehow. It's over the top. And to me, this one looks pretty good. You're supposed to be able to see in this inspection port that these are laying over properly. I've never had good luck actually looking into that, but that's the purpose of that. So I like to just take it apart. So the next thing I do, happy, put it back on. Pretty good. And maybe give it a last couple of bumps with your big bar. Get it fully tight. There is no like locking pin or anything like that that keeps these from unthreading. You know, it seems like with the trawl wire and everything we use, I've never heard of one of these backing its threads off. Makes you feel more comfortable. You could do a line with a paint pen. Pretty much to me, it seems like they've always just held up. I've never seen anything twist on the end of a package to unthread them. Okay, so then you get your wire to this point. Next thing I like to do, take some tape. I usually use some sort of, you know, I like a red electrical tape if we can get it, but something that's relatively robust that gives you clean edge right at the bottom of that fitting. So the next step, and this is going to be a separate clip into the video, is we're going to take a wire that's got a fitting on it, we're going to attach it to the A-frame or water bags or something, and we're going to pull test this 10,000 pounds for 10 minutes. Gives us a chance to make sure everything's setting and looks good. Gives you a chance to check your calibrations against a dynamometer. This should be something you are able to do at sea, so do not rely on just having water bags, because you're not going to do water bags when you're at sea. So have a plan to be able to pull against your, you know, a plate on the deck or A-frame or, you know, a mooring bit, something like that. 10,000 pounds, 10 minutes. And what's going to happen probably is this is going to go clunk and set a little bit, and that there will be a gap. If that gap gets anything more than about a half an inch, probably try again, would be my suggestion. So I'm not a professional at this. I've done a lot of these. This is the way I do them. I have, knock on wood, had really good success with these things. So that's the assembly part of doing an Electroline Feige fitting.